Hey everyone, Mr. Newman here. We're just going to review the quiz. What I'd like for you to do is try all these problems on your own before watching this video, and then I'll explain how to do it. So let's get started. First off, to multiply binomials, I draw a box. So we're going to write x plus 3 there and x plus 4 there. Multiply x times x and get x squared, 4x, 3x, and then 12. Add all those together, and 4x and 3x we combine as like terms. So we get x squared plus 7x plus 12, and that is the answer. For part B, we want to factor this polynomial. First, I need to ask, is there a GCF? The answer is no, there's no GCF across all three of those terms. So, we write factors of 25, and I know that 1 and 25 are two factors, a factor pair, as well as 5 and 5. Which ones add up to 10? That would be 5 and 5. So, let's draw our box and put the first and last term top left and bottom right. Then we're going to put 5x and 5x bottom left and top right. Then we find the GCF of each of those, and that's x and 5, and then x and 5. So our factor is x plus 5 times x plus 5. There's our answer. For the third part C, finding the zeros. First we need to ask, is there a GCF? The answer is no. We're going to find the zeros using factoring here. So we ask factors of 15. I know that they need to add to negative 8, so I'm going to use a negative and a negative. So negative 1 and negative 15, and negative 3 and negative 5. Well, negative 3 and negative 5 add to negative 8. So a squared goes in the top left, 15 goes in the bottom right. Those are both negative, and because they're both negative, I know that my GCFs are going to be negative for the constant terms as well. So a and negative 5 and a and negative 3, that gives me a minus 5 times a minus 3 equals 0. And our last step, now that we factored it, is to write down the baby equations. So a minus 5 equals 0, and a minus 3 equals 0. Add 5 to both sides, we get a equals 5. If you add 3 to both sides on that side, you get a equals 3. So a equals 5 or a equals 3. And those are our two answers. Remember that you can check these by plugging them into the original equation, a squared minus 8a plus 15. Plug in, for example, 5 for a, and you should get 0. All right. Let's do those kinds of problems again. We're going to multiply these, so draw a box. X minus 5 goes on the outside. X plus 5, or x and 5, go on the outside. Multiply to get inside the box. And we get x squared plus 5x minus 25. The 5x's and the negative 5x, those are like terms, so you combine them to make 0. And x squared minus 25 is our answer. Next, for factoring, we're going to ask, is there a GCF? The answer is no here. So I'm going to write factors of negative 8. I need it to add negative 7, so negative 1 and 8, negative 2 and 4, negative 4 and 2, and negative 8 and 1. The ones that add to negative 7 are negative 8 and 1. So when I draw my box, I'll put the top left and bottom right for the first and third term, and I'm going to split the negative 7x into negative 8x and 1x. That gives, now looking for the GCF, that gives us x and negative 8, and x and 1. So x plus 1 times x minus 8 is our factored answer. For the part C, we need to find the zeros using factoring, so I'm going to ask GCF. I'm glad I've been asking that question because the answer here is yes, there is a GCF, and it's going to make it much, much easier to pull it out. So notice 5 is the GCF. When we remove the 5, we're left with a squared plus 7a plus 6. I'm going to factor just the blue equation on the inside of the parentheses in there. And so we need to write factors of 6 and see which ones add to 7. 1 and 6 are the ones that add to 7. So when we draw our box, a squared and 6. The 7a gets split up into 1a and 6a. Find the GCF, and you get a plus 6 times a plus 1. So we have 5 times a plus 6 times a plus 1 equals 0. Well, 5 cannot equal 0, so we can ignore that factor because there's nothing we can put in for x because there's no x there. A plus 6 equals 0 is one possible solution, and a plus 1 equals 0 is one possible solution. When we solve for each of these, we get a equals negative 6 or a equals negative 1. All right. This last part is about connecting what we've done. So we have been taking the square root. In fact, you'll see that in the second part of this video. We've also been factoring, and you guys also can graph this on your calculator. Those are 3 different ways you can solve this equation. Now, I want you to show me that by doing it in all 3 ways. So I'll show you how to do each of these, but we should get the same answer. If we get a different answer for one, we need to go back and check. To take the square root, we need to get x squared by itself. So let's add add 25 to both sides. So x squared is by itself. X squared equals 25. Then we take the square root, and always, always, always put plus or minus when you take a square root. So our answer is x plus or minus 5. That was pretty fast and painless. Let's try to do this with factoring. Remember, you always ask GCF first. No, there's no GCF here, but this is a difference of squares. So the way I set that up is you write parentheses plus and parentheses minus, and the x squared, the square root of that is x, so I'm going to write that in the first spot in each of the parentheses. The square root of 25 is 5, so I'm going to write that in the second spot in each parentheses. And there's our factored form equal to 0, so we're going to set each of those equal to 0. When we solve for them, we get x equals negative 5 or x equals 5. That's great because that is the same answer as before. Then, when we graph this, what I want you to do is notice we plug it into y equals, and you can press trace. You can also do second trace, calculate the zeros, and when you go left bound on the left side, right bound on the right side, and then make a guess, you get x equals 5 for one of them, and you get x equals negative 5 for the other side. So when I say sketch it, I just mean something like this little blue graph here, and then you just mark the 2 zeros. Those are the x-intercepts. Notice those are also negative 5 and 5. Whoops. So what I want to do is I want to notice that all 3 of these answers are all the same. That one, and that one. And since they all match, I'm pretty confident that my answer is correct, and they should all match on your quiz. All right, let's finish with the other side here now with solving the quadratic by taking the square root. So we just did one example problem of that, but let's do these 3. You need to get x squared by itself, so I get 7 equals x squared. Take the square root of both sides. Don't forget your plus or minus. So x equals plus or minus the square root of 7. Notice, do not type this in the calculator, and do not find a decimal approximation of this because, and I'll type this on the quiz, I want you to have an exact answer. That means leave it as a square root. We can't simplify it because there's no perfect squares inside of 7, but don't type that into the calculator to get another answer. This is actually your final answer. I will share at the end why you might want to type it in the calculator, but not to get a better answer. All right, for this one, we're going to add 4 to both sides. So 9 equals x minus 2 squared. Take the square root of both sides, and don't forget your plus or minus. The square root of 9 is 3, so we write plus or minus 3 equals x minus 2. For this one, I'm actually going to split it up into 2 equations because we need to write both numbers. So positive 3 equals x minus 2, and negative 3 equals x minus 2. Now we can solve each equation, and we get 5 equals x and negative 1 equals x. Those are our 2 answers. Whoops, sorry. 5 equals x and negative 1 equals x. All right, for the third one, we need to get the x squared component by itself, so add 6 to both sides. We get 2 times x minus 8 squared equals 6. We need to divide this by 2 now. We're still trying to get the parentheses squared by itself. When you do that, the 2's divide out. So we get x minus 8 quantity squared equals 3. Take the square root of both sides and remember your plus or minus. X minus 8 equals plus or minus the square root of 3. Add 8 to both sides and we get 8 plus or minus the square root of 3. Now we could write that out in 2 separate equations. We could write 8 plus the square root of 3 and 8 minus the square root of 3, and that would not be wrong, but it's also okay to leave it like that. Now I said don't type it in the calculator because when you're answering these, you don't want to answer with a decimal. However, then this is the final answer. However, you can check your work with a decimal, and the way you want to do that is just like what we did on the end of the last problem. Type it into the calculator, into your graph, and see if when you type in 8 plus the square root of 3, if that's really close to one of the zeros, you can check your answer that way and make sure that you got the right thing. Notice you can't get the right answer by graphing it because that doesn't give you a square root. But you can check your answer that way and make sure the square root you found is the same as what the number on the graph is. All right, thank you very much for watching.